And so we would like to start this meeting. Okay?
Yes.
Okay, so can I share my slide?
Sure. Wait a minute. Wait a minute. Okay.
Okay, can you see this slide? Okay,
Yes.
Robert? Okay, so I think it's time to start, as well as our guest speakers are already in the meetings. So I would like to start this meeting. At first, welcome everyone to the third Data Space Working Group meeting of this Asia Open Data Partnership, AODP. Thank you all for joining us today. Before we begin, since working group's chair, Professor Koshizuka is not here today due to his other important business. So I would like to act as a chair instead of him by his request. I'm Kazuma Hatano, Associate Professor of the University of Tokyo, and I have served as Secretary of this working group together with Erika-san. So let's move on the next slide and let me introduce today's guest speaker. Okay. So the first speaker is Dr. Inda Gopal from IUDX, India Urban Data Exchange. He will make a presentation how data spaces are improving lives for India's citizens. The second is Dr. Wen Wei from Big Object. He will make a presentation on UN Action Days report sharing. Each speaker will make a presentation for around 20 minutes, and it is followed by Q&A session for around 20 minutes as well. After that, we close this meeting. This is today's program. Yep. And to start my introduction session, I would like to look back on the position of this working group in a few minutes before starting their presentations. As you already know, a data space is a concept of data platforms to facilitate trusted data sharing among multi-parties. This concept happened mainly from Europe, and there are many initiatives in Europe, such as Gaia-X, International Data Spaces Association, IDSA, Catena-X, but now it has extended to Asia, I believe. So Japan has some data spaces initiatives like Data-EX and Uranus X system. From global point of view, data free from with trust has become widespread, and the institutional arrangement of partnership (IAP) was established in OECD. AODP has been dealing with open data, and data space is not only for open data, but the concept doesn't preclude open data as well. So we started this new working group to study and share information about data spaces and discuss the role of open data in data spaces. We already held two working groups, and this is the last meeting. As out of this working group, we are going to prepare a report and input it to AODP 2024 Summit, which is held next month. We will make the draft report after this working group session and share it with you in order to receive your comment. Oh, okay. So this is a data spaces week, including AODP Summit 2024. As you already know, and I believe so, AODP Summit will be held next month. But that's not all for the week. So I would like to introduce the Data Spaces Week 2024 at this opportunity. We have 5 events regarding data in this week. On the first day, there is DSA Open Forum. This forum mainly for Japanese stakeholders to discuss linkage of data. Next day, IEEE 3800 will be held in the morning of October 8th. It is a working group of IEEE to discuss to draft a standard for a data trading system. After that, there is our AODP summit in the afternoon. On that day, each participant shares their status and representatives from OECD and IBSA will join. On Wednesday 9, we will hold a joint symposium, AODP and IBSA. We believe it is a good opportunity for AODP members to know all the data spaces activity in Europe and Japan, as well as to meet those people to discuss. We hope many audiences come and utilize this opportunity. At last, International Open Forum for Data Society, IOFDS, will be held for 2 days. This forum brings together key members involved in Data Federation to discuss. You can see the details through the URL showed upside of here, this slide. Please check and join this event. So, just a moment. スライドショーを共有。Just a moment. 停止か。Oh, that's all my introduction. Now, I'd like to hand it over to our first speaker, Dr. Inder Gopal, CEO of India Urban Data Exchange, IUDX. So, Gopal-san, please show your slide and start presentation, please.
Okay, thank you. I can share my screen, I guess. Optimize, click share. Okay, let's see. Window. Okay, I'll share the entire screen. Let's see if that works. Can you see my screen?
Yes, I can see.
Okay. Okay, so I think what I'm going to do is try to give you a sense of how we are using data spaces in India, and in a variety of different sectors to help Indian citizens to create public good. Right. So the work is done with various partners, but it's mostly coordinated through the Indian Institute of Science, IISc, where I'm a faculty. So just to give you a little bit of background, we have something in IISc called the Center of Data for Public Good, which was formed in 2023, so it was last year. And it is really to help build what's called digital public infrastructure. So digital public infrastructure is a term that, is in common parlance in India. I don't know whether it's, equally well known in other parts of the world, but it's digital public infrastructure is something that comprises, a lot of the technological underpinnings, right, of various aspects of the way in which government deals with the citizens. So they're typically considered to be kind of three aspects of digital public infrastructure. There's identity, proving a citizen's identity. There's dealing with financial payments, financial transactions. And then there is data exchange, right? How do you exchange data, both between the government and citizens, between government and businesses, and between businesses and businesses. And our focus is really on the third aspect, on data exchange. And we are trying to create the know-how, open source code. Everything we do is open source, best practices, use cases. We're trying to work on policy and economics as well. And everything we do is based in real experience, right? So we are not just doing some academic research. We are actually building systems, production systems, deploying them, and delivering value to citizens with what we do. So our view very much is to learn by doing, right? And to actually deliver value as we are doing things, because our perspective is that these are not areas where you can just kind of think about what is the best approach. You actually have to implement things and build them. So we have built a variety of different programs, with significant scale, right? So IUDX is the best known, and it's something that has been going on for about 4 or 5 years now. It's an urban data exchange, a data space that now is across 52 different Indian cities. Right. So, and you can imagine Indian cities are very big. And so, the scale of supporting these cities, especially the mega cities like Bangalore or Chennai, you have, maybe 20 million people, resident. So these are large, extremely large urban bodies. And most of what is being dealt with in IUDX is IoT streaming data, right? So this is data from sensors, data from cameras, other kinds of devices, but real-time data. And so these exchanges have to operate in real time. They have to enable activity in real time. I'll talk a little bit more about each of these things. I'm just giving you a slight an overview here, and then I'll come back and talk about each one a little bit more in detail, maybe give you some examples. Another exchange that we've been working on in addition to IUDX has been something called ADEX, Agricultural Data Exchange, right? And that is with a state in the southern part of India called Telangana. So this exchange is operational within Telangana. And the key characteristic of an agricultural data exchange is the data is the whole variety of different kinds of data. Some of it might be IoT streaming data, as we had with IUDX, but a lot of it is also personal data, that is specific to a farmer, because you cannot make a lot of decisions especially you cannot give services specific to a farmer till you know that farmer's information. And so there are issues of consent, issues of privacy that are extremely important in ADEX. Another kind of exchange that we're working on is with another state in the northern part of India related to public benefit data. I'll talk a little bit more about that. And then we have work that we're doing with the Survey of India on geospatial data, something called UGI, a Universal Geospatial Interface, which has large-scale geospatial data. So the characteristics of this is that the data sets are enormous. And the data sets are also dynamic. So you have remote sensing data, so every time a satellite is taking images, these images are appearing. And so the volume of traffic that is being generated and the volume of data that's coming through is extremely large. So this is another project that I will briefly talk about. And then the final thing is epidemiological data, right? And the characteristics from the Indian Council of Medical Research, which is our premier medical research institute in India, government-run medical research institute in India. And it is dealing with public health data, but also a lot of sensitive health data, extremely sensitive health data. So the issues of privacy, of ensuring that you can do secure computation, that you can, get data from maybe 2 different hospitals, do some kind of computation on that data, and get the result in such a way that the individual data that's coming from these hospitals is not divulged to either party. So they get the result of the combined data or the analysis that's coming out, but they don't get the individual data itself. So that requires some kind of secure computing environment that we will talk about a little bit. So all these different exchanges have a common architecture, and I'll briefly talk about the common architecture, and then I'll just go through a little bit more detail on each of these different projects. So the architecture of the data exchange, the generic architecture, the canonical architecture of a data exchange is given over here, right? So if you look at this, there are three layers. There's the layer below, which is the data sets, right? So these could be public, private data sources, could be personal or non-personal data. They could be IoT streaming data. They could be repositories and data of repositories, databases, legacy data. So it could be a variety of different sources of data. These exchanges have to deal with all of these different types. On the top, you have the users of the data. So these are the providers at the bottom. The top is the users, the consumers, right? So you have applications, use cases, you have training of AI/ML models. These things could be done by governments, startups, industry. There could be a variety of different sectors that are using the data. So these are all users building applications and services. And in the middle is the exchange. So this is a cloud-based infrastructure sitting in the cloud. It's entirely open source. So if any of you is interested in getting access to it, we can give you the access to the GitHub repository. You can download and start using. It consists of two pieces. There's a control plane and a data plane. Right? The control plane manages the kind of the access and allows you to find and access data. Right? So it provides a catalog server that has metadata that describes the data, as well as it's programmatically searchable and lets you understand what data is available, either programmatically or as a individual through a user interface. And then there's the authorization and consent server that deals with access to the data, right? Once you found the data, you want to get access to it. The authorization and consent server ensures that the access is secure, that you have the right to get access to the data, deals with issues like privacy, ensures that the policies for access that are set up by the data providers are adhered to. Also ensures things like payment and other mechanisms are enforced, right? So that is the control plane, and then the data plane consists of three pieces. There's what we call a resource server, which essentially deals with the format of the data. The data can be in a whole variety of different formats, right? It can be there may be different ways of representing the same data, right? What this resource server does is it normalizes everything. So in runtime, right, as the data is being transferred from the data provider to the data consumer, the format of the data is appropriately modified to conform to the standard open data models, to ensure that an application doesn't have to deal with all the heterogeneity that exists below. And then on top of it, there's a privacy framework which protects personal data. So we will briefly show you a little bit about what's going on there. And then there's an analytics framework that provides AI/ML framework. It provides a whole variety of different insights into the data. So you, as an application developer, you don't need to recreate these insights, right? These are already there in the platform and available for you. The data itself is not stored in the data exchange, right? So the purpose of this exchange is to enable the sharing of data in a controlled and secure and standardized fashion through standardized APIs and standardized open data models. But there's no data that's stored here. Usually it's stored in there may be some data that's cached or some analytics data that's stored, but for the most part, the data is stored in the data provider. So the data provider is not giving up control of the data. And these systems are federated, right? So there isn't a single data exchange that deals with everything. There's a whole variety of different data exchanges, and they connect to each other, and they can give the appearance of a large centralized data exchange without necessarily operating as a single centralized instance. And as I said, everything is open source, right? Which is a very, very important aspect of digital public infrastructure. So this is kind of the generic architecture of a data exchange. So what I'm going to do is just briefly give you some idea of the different projects. So if you remember, I talked about the IUDX project before, the India Urban Data Exchange. That is deployed in 52 cities. It looks a lot like this picture here, but with some optimizations for the urban sector. The kind of data that we deal with in IUDX is shown on the left-hand side. We have environmental data, we have transit data, we have solid waste management, street light, a whole variety of other kinds of data sets, citizen safety. If you go to iudx.org.in, you can browse through things and you can get a good sense of what it is that that's available there. And then there's the whole bunch of use cases that are being developed, right? I mean, the purpose of an exchange is not it's not intended for individuals, citizens, to go and look up data. That's not the purpose of the data exchange, right? The purpose of the data exchange is to enable applications, right? So if someone is creating an application to do flood analytics, right, and to predict floods in Indian cities, we want them to be able to have API access and be able to access the data in a programmatic fashion so they can do something of value and deliver a service to citizens. The purpose is not here for a citizen to go and browse through the data sets individually. That's not our objective. We are not trying to create a portal. We're trying to create an exchange. Right? So there's about these are some samples of the cities. I mean, I don't know if any of you is familiar with Indian cities, but if you are, you'll see that there are some large cities on here. There are some mega cities like Bangalore. There are some very small cities, right? You'll see, for example, here, cities like Kohima, like Dharamshala. These are all cities which are significantly smaller. So the idea is we have a scale, right, of cities from very small to very large, and the idea is very much to enable something that can span that scale. I don't want to talk. I mean, I have a couple more slides on some of the use cases, but I don't want to get into too much detail here. In the city of Varanasi, for example, we implemented a solid waste management optimization program. Okay, so just to give you a sense of this, right? We built the system, we built the platform. We brought all the data was provided by a variety of different sources, by instrumentation from the garbage trucks, which was done. The position of the garbage trucks was sensed by the sensors that have been put in by the company that picks up the garbage. There's sensors on the garbage bins. There's various other data that's coming into the system related to crowd densities and so forth that come from maybe cameras in different parts of the city. So data is coming from many different sources, right? And the application in this particular case was written by a particular company, right? Actually happens to be a Japanese company. I wouldn't mention the name, but they built the application. We have IUDX is in the middle. So IUDX is getting all the data, exposing it through the common APIs, and then this company built the application, and the application is now delivering services to the city of Varanasi, right? The city of Varanasi is the user. And what they are doing is they are using the application to optimize the movement of the garbage trucks, right? So rather than having the garbage trucks in the city of Varanasi, you take a fixed route every day, right? Which is typically what would be done. They look at dynamically at where's the garbage, where's predictively, hey, where are the people collected, where may they, where is it likely that garbage will be building up, and the trucks move in a way that is optimized on a day-by-day basis, right? And if, for example, you have, say, a driver, that doesn't show up, you have to compensate for that. You can modify the schedule dynamically. So this is sort of an optimization in terms of a route, the pickup routes. And it turns out that by doing that, you can cut the cost of the overall system by something like 30%, right? So just by taking this data, doing some optimization, and modifying the traffic pickup on a day-by-day basis, you can reduce costs by 30%. So this system was actually implemented, and it was trialed, and is now in the process of being rolled out across the city of Varanasi. So another example is citizen safety, just to give you another very brief idea. In the city of Pune, which is another big city in the western part of India, we have data that comes from street lights, from video cameras, from historical crime records, their property records that tell you what the each building is being used for, and based upon that, you can actually get a pretty good idea of the safety of an individual street. This is for a pedestrian, right? So particularly women who are walking through the city, say back from their jobs or something in the evening, they would like to be able to find the safest path, not the shortest path, but the safest path for walking through the city from point A to point B. And what we are able to do is get all this data, and we have partnered with a company, a small company called SafetyPin, to create a safest path for pedestrians walking through the city. That takes into account, where are the street lights, right? Which street lights are working, where are the video cameras, all these kinds of things, and where are the crowds, right? So, for example, in some cases, crowds may be a good thing if it's a very say family-oriented crowd, where there's women and children. You may say, well, it's good. Let me walk through that, because there are lots of. It's probably a safe area. On the other hand, if the crowd is entirely made up of, young males, right? Maybe it's not an area that you want a woman to be walking through, right? So these are the kinds of analytics that can be done, and SafetyPin is working with us to do a lot of that analytics and create a safest path through a city. So I have a couple of other examples. I'm not going to go through details here. I can, if you will, but if you want. But I'm not going to bother. I'm not going to do that right now. I want to talk briefly about some of the other projects that we have. I mentioned to you ADEX. ADEX is a data exchange for agriculture, and again, we're getting data from a whole bunch of different places, right? Soil health, pest advisories, land holdings, crop history, farm records, multiple data sources. Some of these data sources are from the state government, some of them from the central government, some of them from private data sources. Like, for example, we have micro weather data, right? Weather data, for very, very small areas, very specific small areas. This data is coming from a private provider, right? We have data from drone surveillance data that has been collected by private providers and has been provided. So these are all a mixture of private and public data sets. And on top, we have a variety of different applications, right? So the application that's particularly interesting, which has actually just been launched and is available now, is something called Smart Credit, right? So just to give you an idea, in India, most of the farmers are subsistence level farmers. They're pretty poor farmers. We don't have large agricultural businesses. We have small farmers who farm land, and many of them don't even have the proper title to the land, right? So they don't have the ability to even prove that they own the land. So when they go try to get a loan from a bank, it's very hard for them to provide the documentation to satisfy the bank, right? And what we are trying to do is use data to enable the bank to make a better decision using data, right? So what the bank will do, I think I have this somewhere. Okay, I don't know. What the bank will do is I have a picture here. I don't know. I mean, it's a slightly complicated picture. I apologize. But basically what you can see at the bottom here is a whole variety of different data sources, right? Government records, various data sources coming into this ADEX. This blue box in the middle is the ADEX data exchange. And then on top of that, the bank or some third party would write a credit assessment application, right? That would use data that comes from, once they get a loan application, they know the farmer identity, they know where the farmer is, what crop the farmer is trying to grow. And then rather than making a decision just based upon the information the farmer has provided, what they will do is go and search for data, right? And they will search for data that relates to what are the crop yields, what is the weather patterns, what are the pest infestations that have occurred, what is the likely history, based on history, what is the likely crop yields that the farmer will have, and consequently, what kind of revenue that the farmer will see, over the next several years. So they would make some predictions on that basis, and then use that information together with what the farmer has provided to make a much more accurate credit assessment. So this gives you an idea of how data is used to help farmers. I'm going to skip over a couple of these other slides because I think I'm running out of time. There's work that we have done on the geospatial data exchange, which is actually very exciting, and it's going to be launched as a national project very soon, including data from Survey of India and NRSC, the National the National Remote Sensing Agency, which is the India's satellite mapping service. And all the data again is coming through this exchange and being normalized and being presented in a common way so that you can get applications and services built on top of that. I think I'll skip this. I mean, actually, let me just mention here very briefly, and then I'll stop. I talked a little bit about personal and sensitive data in the past, right? I mean, I talked about dealing with farmer data or dealing with health data. These are very strong privacy considerations, right? And we've got a lot of work going on building technology that will ensure privacy and security in a automated way, right? With that, and ensure that, right? So in a way that's consistent with the laws the privacy laws that have been put in place. So I mean, if you see here, you'll see a hierarchy of data, right? You'll see at the bottom open data, so things like government statistics, air quality, these kinds of things are open data available for all. All you need to do if you're sharing that data is standardize on APIs, on data models, on metadata. Maybe you have to consider, some of the analytics capabilities, and maybe standardize some analytics pipelines. But it's relatively straightforward if you're just sharing open data, right? The next level above is high value data, right? So this is data that is maybe non-personal in nature. It doesn't have privacy considerations, but it has significant value in the sense that someone has spent a lot of effort creating this data. It may not be publicly funded data, maybe private data, or it may be publicly funded, but in a very way that has required a significant amount of investment. So the party that is sharing the data is not willing to give the data out freely. They want some compensation for it, or they want some agreement with the user of the data. And so in addition to all of the things you have to do for open data, you have to provide things like authorization, policy-based control, catalogs, scaling and federation. So this is sort of taking data, open data, to a next level, right, in terms of creating value, allowing the sharing of data that has significant value. And IUDX is very much a platform that allows you to do that, right? So IUDX, ADX, in fact, all the technology that I've talked about so far allows you to share high value data. But then on top of that, you could have personal and sensitive data, right? Which health data, financial data, right? Farmer holdings and crops, maybe things that have security information. So here, the kind of technologies that one has to deal with are over and above what you deal with below. They include things like de-identification, providing a secure computing layer where you can share data from different sources, compute something based upon all those inputs, and deliver the result without divulging the individual data, right? So technologies like, for example, differential privacy, that's what DP stands for, secure multi-party compute, homomorphic encryption, trusted execution environments. These are all cryptographic techniques that play an important role here, right? And obviously that also relates to things like training models in a secure fashion. Suppose you want to bring in personal data and train a model without divulging the personal data, right? How do you do that? And so again, we've created those kinds of environments that allow that to be done. Federated learning is another aspect of doing AI ML techniques, but in a way that is decomposed and distributed, right? So you don't do the learning in one place, you do it in many different places, and then you combine them, right? So the potential security exposure is less. So these are all some of the techniques that we've brought to bear, and we've actually built a platform called Pre3DX, which I don't have time to talk about, but it embodies all the protection for personal and sensitive data. So anyway, I think I've probably run out of my time, so I'm going to stop here, and then I think if there are any questions, I'm more than happy to answer them.
Thank you, Gopal-san, for your presentation. It was so insightful. So now let's move on to the Q&A sessions. So anyone who have any question, please raise your hand.
Yes, I have questions.
Yes.
Hi,
Erica-san, please.
Dr. Gopal, thank you for sharing your slides and the presentation. And I also found there is a lot of the real case, as you mentioned, it's not just academic, but it's the real case in India. And because in the process when we develop and try to promote the idea of the data space, we found there is like a challenge or an issue is that what is the business model of the data space? Because the some of the data providers they can overcome the challenge of the technical by for example you mentioned there are a lot of the modules or the techniques can help us to protect the private issue, but if they don't have the trigger to make them like to share the data. For example, what is the how can they earn money from the data space? They may not willing to share the data. So my question is, can you share more information about the do this case they deal with the issue about the business model and why they would like to join the data space? What can they get or what can they earn from that?
Yeah, no, that's an excellent question. And I think if you don't have an economic model, a business model, as you say, it's very hard to make something that's self-sustaining, right? I mean, there has to be a business model. You know, sometimes the government can play a role in establishing these things and setting them up, but in the long term, there has to be a business model that keeps them going, right? And so I think a couple of things in what you said. I mean, I think one question was, what incentive do the data providers have in sharing their data? Why should they share their data? So there are a couple of different things, right? I mean, one category of provider of data in our systems are government entities. Right? These are government entities that have collected the data. And they are actually obligated to share the data, right? So, I mean, if data, I mean, it's a policy. It's not legislation, but it's a policy in Indian government that if you have collected the data using government funds, right, you have to make that data available to the public, right? Now that doesn't mean you may seek some reasonable compensation for the data, some fair compensation, but you cannot keep the data, to yourself. Now, that's the theory. In practice, it doesn't really work that way, right? In practice, you find very often that there are lots and lots of government agencies that collect data, and they have no interest in sharing, and they just, nobody asks them. They just keep it to themselves, and the data doesn't get shared. But at least in theory, there is a mandate the government has, or a policy the government has, that says if it's it's collected through public funds, it should be shared. Right? So that's one answer. Then another question would be, how about private providers? Why should they share data, right? And I think, again, there's many reasons, right? But fundamentally, there is some compensation that they would expect from that data, right? So they are data providers. I mean, they could create value from that data and then, operate their business or, deliver some service, or they could try to see, can I monetize that data directly, right? And so, for example, we have many drone operators who have done mappings of agricultural areas, right? So they've created these maps at their expense, right? They put this data on our system, and they expect to be compensated for it, right? So they expect that when you use the data, you are going to pay for it. That data is they give you, they don't let you take the whole data. They'll give you API access to data, so you cannot just simply copy the entire data set. You have to so you only get access to the data while you subscribe. So they sell subscriptions to the data, right? They sell subscriptions to that data set, right? And that's a business model that people are willing to pay for, and it's something that they seem to find compensates them adequately. I mean, there are other ways in which they could get compensated. For example, sometimes it isn't just a transaction, right? It isn't just I give you data, you pay me for the data. It is I give you the data, and then I come to some agreement with you that when you generate value out of the data, I then get value back, right? So you may, for example, have some revenue share model, right? That you can put in place. So there's a whole variety of different things that people have come up with, right? And some of them work reasonably well. Some of them are still in the process of being worked out. So anyway, I mean, I don't know if that answered your question adequately, but we've done a lot of thinking and working on this in terms of things of pricing models, in terms of putting in place support within the platform itself to enable this kind of commercial transaction, right? So we've done a lot of work on that.
Just to add on what Dr. Inder Gopal mentioned about the examples, I come more from the applicability side of it in India, and how we have been helping startups to monetize on these public infrastructure data frameworks. A use case I can share with a large Japanese tech company. We got this startup to train the algorithm using the public data. And they got the machine learning using the public data in the healthcare space. And now, definitely, they have created an IP around that. Approvals from the respective authorities globally, and they a solution to the radiologist in the industry. So the monetization is a win-win. While they are creating revenue out of it, at any time they are calling the API, as Dr. Inder showcased the framework. We through this startup we pay for every API call. It's just like the Google Map model on the Uber car. So every time there's an API call, Uber pays to Google Map. So it's the same model on which it works. In this case, we have done, and it's quite a fast-growing startup from India. Now it's a global company now. Similarly, we have done it for the automobile sector using the public data. We are training the algorithm using machine learning, artificial intelligence, where we are predicting not only the probability of a high footfall of a car selling network in the country, because it's a very expensive proposition for the automakers in the country. So all these application layers, I think, are using it and monetizing it, and it's a win-win. The APIs, whenever it is being called, for every API call, it's been paid. Similarly, we have done in agriculture. In fact, in one of the slides I saw, Dr. Inder Kumar says Cropin is a startup from India, and they have done a phenomenal job in the agriculture space. So there are many monetization models emerging from India in the data space.
Yep.
Thank you for.
Sorry, go ahead. I mean, I was just trying to see if there's any other questions, anything else.
Okay, thank you for your discussion, and any other comment or question from AODP members? No. Okay, so this section, I'd like to move on to the next session. Okay, so next is our second speaker, Dr. Wenwei San, so co-founder of Big Object Taiwan. So Wenwei San will make presentation about the UN Action Days report. Okay, so Wenwei San, please show your slide and start presentation.
Hello, everyone. Let me be clear that did everyone can see the screen on the presentation?
Yes.
It's okay. Okay, good. Let me check. Okay. Okay, so thanks for the host introduction and good evening, everyone. I'm Jenny, as the Director of the Business Development and the Sales from Big Object. And in this meeting, our Chief Executive Officer and also our founder, Dr. Weng Wei, is also joining us today. And our CSO, Alan, is on the airplane because he's just end of the conference in the United Nations last weekend and fly back to Taipei now. I think he's on the airplane. So I will be helping to share the information today. And we have been pleasure to be invited to the event hosted by the UN called Summit of the Future Action Days, and Alan was in that event. So in this evening, we would like to share the topic. It's called the Summit of the Future Action Days UN Conference Report Sharing. And before we sharing the report from the UN, I'd like to briefly introduce about Big Object. Okay, so our company, Big Object, is a technology company dedicated to developing and innovating cutting-edge data technologies. And we hold over 20 patents and had extensive experience in various data projects. And our vision is to transform how people utilize data. And as pioneers in the high-performance temporal data technology, we are committed to build the next generation data ecosystems. And we have three major products. On the slide, you can see the first is called BO Lightning Fast Time Series Database. And it contains our features. It's called the core in data computing technologies, which delivers top performance. And the second one is called Bona, a multi-data source integrations platform that serves as an end-to-end data solutions for like data collections, ETL, and data management things. And all in these functions within the web browser's environment. And finally, our flagship product is called Aurelia, which incorporates two main technologies. One is the cross-data synergy mechanisms, and the other one is called actionable AI. And we offer innovative technologies that enables interoperable between data platforms, which allows data workers to do the synergy insights from diverse and various data sources and protect their data ownership. And over the past few years, we have the opportunity to serve the customers across various industries, including like retail and distribution, manufacturing, media, gaming, and public sectors. And in particular, our public sector's clients, including the national government bodies, such as like the Ministry of the Transportation and Communications, the National Center of Science and Technology Policy Research and Information Centers, and also our partner, National Center of the High Performance Computing. We continuously track trends in like data democracy, including the database technology and data governance. And with the recent rise in the popularity of generative AI, we are now looking forward to how the interactions between data and AI which transform our future. And this is why we participated in the Summit of the Future Action Days in New York last weekend. And it was our pleasure to attend that event. So now I will hand over the microphone to our CSO, Adam. Although he's on the airplane, but he recorded a video last night to share his experience at the conference and explain the connection between the UN and data space. So I hope the internet is well, and let me just play the videos, and Ellen will just have a talk with us.
Hello, everybody. Alan Wang, Chief Strategy Officer of Big Object here. On behalf of Big Object, it was a great privilege to have such a very concentrated and comprehensive overview of the global digital agenda, which I'm about to share with you right now. We have been following United Nations initiative on data since 2019. When it first published a technology frontier quarterly data economy, whether it's a radical transformation or a dystopia. This year, it marks the first year of Digital Future Forum and the second year of SDG Digital. They have included and invited entities that have contributed to the digital development in the past to participate in this forum. The forum was packed into 7 sessions, spreading over 3 different acts in a 1 full day forum organized by the United Nations. And there were 65 speakers altogether, including presidents, ministers, CEOs. I just happened to have, was able to spend a short conversation on data with AI with Google CEO Sundar Pichai. The rest is head of states representing governments, companies, NGOs, schools from all over the world, and the United Nations representative itself, sharing everyone's stories and perspectives about the digital impact of lives. Hence, the name of yesterday's theme, A Digital Future for All. On a side note, there were 2 other themes as well in parallel, namely a peaceful future for all and a sustainable future for all. But by far, A Digital Future for All has the most attendees. The day started with the United Nations Secretary General's keynote. In short, he warned of the challenging and chaotic world situation on conflict and climate change. In essence, is losing the strength of multilateralism that represents all walks of life. He called for the use of technology and the Global Digital Compact be the footprint to close digital divide and a universal agreement on artificial intelligence, laying the foundation of global platform that bring all access together. I'm about to begin with the first session of the 7, which is Welcome to the 2030. So as you can imagine, they're trying to take a peek, take everyone to take a peek of what's potential, resides in the 2030 and the goal together as the world citizen. It says that in a futuristic and scenario-based exercise, the session explored the trends, risks, and opportunities shaping our present and future through the lens of digital technology. The topic include a cook in Thailand shared the recipe online, and within hours, people are replicating it in their own kitchens. In merely moments, that recipe transcends borders. That's intriguing. Blockchain, meanwhile, has provided disposition Ukraine refugee families the financial aid to rent a home outside of Ukraine that they have fled to within a matter of 15 minutes. So digital access is a game changer, starting from government setting digital policy to establishing capacity for community citizens so that everyone, everywhere can access. Through the multinational partnership, United Nations and private sector to form digital partnerships, the future is digital. It must be secure, safe for all to access. So the inclusion was one of the major themes in terms of accessing to technology. Future generation came to this world of digital, SDG generation, as the United Nations called it. Pandemic situation has shifted the education online, most connected generation of all. Give them a seat at the table and let the future generation decide their future. Algorithm provides quality and not biased, sustainable inclusion for all is the goal. 2030, security from threats, gender gap via digital technology. Developing countries are competing for AI and digital technologies. The age of possibility via digital for SDG goals of 2030. Thanks to technology, all children have the same right, early warning system, everyone is protected. Technology is about life, not just technology. It's about the transformation to a closing digital skills landscape. AI ecosystem and digital equality and digital destiny are well touted within the whole session. The second act, which leads into the second session, is called A Digital Future for All, Universal and Affordable. There are still 2.6 billion people are unconnected. So we're talking about a digital future. If somebody's still not connected to the internet, it's just impossible to do. The game-changing situations that they share here, one of the gentlemen, I think it's the EVP from Amazon, shared that their Kuiper project is called the Project Kuiper. Is in the process of launching 3,200 constellation of satellites circling around low Earth orbit with broadband network, fast, affordable, and reliable connectivity. This is one way technology is to solve and fast, forward with the backward areas to be connected, and they call it to connect the unconnected. Session 3, A Digital Future for All, Inclusive and Meaningful. A digital future for all is one that is inclusive and meaningful, and that will leave no one behind. It also makes the most use of digital and emerging technologies to create value, promote inclusivity, and provide a safe, satisfying, enriching, and productive online experience where everyone has the capacities and skills to thrive. The example cited in that session was Google bringing artificial intelligence into problem solving. There were floods in India due to climate change, and it has always been the aftermath analysis until last year they were able to predict. They actually provide a flood forecast before it struck. And so the government, the early reactions or the early responder were able to vacate the local residents in order to save lives. Another example is something called the push to walk, a robotic walker game changer. A woman after disruptive injury of broken spinal bones, she now works for a New Jersey company that does from chair to walker self-balancing skeleton after 7 years of immobility. And literally she was on site. She stood up from the chair that she was sitting in and walk. And think about, according to her, there were 42 broken bones in her, and including her spinal bones. She's now able to walk. It's thanks to the New Jersey company that it actually memorized her muscle memory. And this is just an impressive on-site demonstration yesterday. There's another thing that's going on in South Sudan. It's called the I Am the Code, which United Nations provided meals to help refugee girls at school in order to close the gender gap in terms of accessing to technology. In this case, particularly for women to receive education. And the head of the organization has pledged 1 million young girls coders by 2030. Okay, artificial intelligence, generative AI specialists among them. Their slogan is, "Today I'm a refugee, tomorrow I will be a coder." Ministers of information from Egypt has cited an example that their governments provided free scholarship to 50% of the population to learn digital skills. 50%, usually in all societies, is divided between male and female. And so it increases the job opportunities rather than taking away in terms of the technology. Another example is Salesforce. In the case of the World Central Kitchen, WCK, from compassion around the world, being driven by digital power of food to provide those who are in need around the world. So these are the success stories in that session. The coming session, which is a digital future for all, sustainable and prosperous. This particular event was entreed by the Saudi Arabia's Minister of Communication and Information Technology. He started off by saying the cost of gender inequality worth $7 billion for Saudi Arabia. Gender equality through the digital skills helped diversify economy, internal space that they were able to send as an example of success to space of one of the Arabic women's astronauts. AI Advisory Board of United Nations, a member of, which includes Saudi Arabia, they are empowering women in their country, which represents 50% of that country's economy and therefore the prosperity. By working with the United Nations International Telecommunication Union, as well as Microsoft, in achieving the 2030 SDG goals. The next session, risks, challenges, and opportunities of emerging technology. Emerging technology like artificial intelligence and quantum computing have immense potential to tackle humanity's toughest challenges, offering breakthroughs in climate change, healthcare, and global inequality. The session examines the frontiers that have been pushed in the development of this technology and models, regulations, as well as controls to make sure that they help realize a digital future for all. In this case, very interestingly, a Japanese company called Astroscale, they want to make sure that the space is sustainable. You do realize that after standing and relying on so many satellites for the internet access and disaster response, the space has become crowded. They're flying around the Earth. A congested space could set up for collision Just one collision may cause millions of debris that could sabotage mankind for generations to come. Imagine the impact. And the gentleman who introduced this idea gave an example that says any debris that travels, it could travel in the speed of 7 kilometers per second. An astral scale uses satellite with robotic arms to remove, relocate, and repair fast-moving satellites today. But for debris, it's just the beginning. They were only able to capture the first debris image this year. And be able to see it the eye contact is the very first step before you can do anything about it. But interesting, people are looking at the space sustainability, and it becomes an imperative, for the future to secure. Going into the Act 3, which is laying the foundation of digital future for all. This has everything to do with the Global Digital Compact, which, I'll be able to share some of the details with you. There's altogether they put together a full document with regard to the Global Digital Compact that has been negotiated, worldwide, and I'll go into the details for you. Basically, in these two sessions, part 1 and part 2, it emphasizes the importance of partnership, the legal framework, and digital public infrastructure as key foundations of a digital future for all. It explores the core principles and objectives of the Global Digital Compact, a GDC in short, through a dialogue aimed at translating visionary aspirations into collective commitments, laying out the foundations of a digital future for all, with a focus on the transformative potential of artificial intelligence. Technology can be guided to serve the greater good, ensuring its advancement benefits for all of the humanity. Global Digital Compact, GDC, is a comprehensive framework for global governance of digital technology and AI. After 20 years of the World Summit on the Information Society, it charts a roadmap for global digital cooperations to harness the immense potential of digital technology and close digital divides. It was negotiated by 193 member states of the United Nations and informed by global consultations, including private sector, technical communities, researchers, and civil society stakeholders. The compact commits governments to upholding international laws and human rights online to take concrete steps to make the digital space safe and secure. It pledges, at the same time, a range of ambitious actions to close all digital divides and deliver an inclusive digital economy, build an inclusive, open, safe, and secure digital space, and last but not least, to strengthen international data governance and govern artificial intelligence for humanity, which includes support the development of interoperable national data governance framework, establish an international scientific panel on artificial intelligence and a global artificial intelligence dialogue. Third, develop artificial intelligence capacity building partnership and consider in options for a global fund on AI. In fact, they already established a such fund, to be accessible by member states and by the interest party in contributing to this digital future for all. In the Governing Artificial Intelligence for Humanity, published by the United Nations this month, it was fresh out of the oven in September. And for the interest of the Asia Open Data Partnership interest, it recognized the capacity of access to quality data and facilitating to quality data at scale for training artificial intelligence models by startups, small and medium enterprises, as well as mechanisms to compensate data holders and creators of training data in rights-respecting ways. It might be the most important enabler of a flourishing artificial intelligence economy. Pulling data together for the public interest in furthering specific SDG goals is one key aspect, but that is not all. Misuse of data, i.e. infringing on privacy, or misuse of data, meaning failing to exploit existing data sets, and missing data, meaning regional data poor. There's certain regions of this world that just simply don't have data. One example is healthcare, where around half of the leading data sets can be traced to a dozen organizations, with one in Europe, one in Asia, and the rest in North America. Another example is agriculture, where data are required across a complex interplay of factors such as climate, soil, and crop management practices to enable useful AI models. They often suffer from paucity of data and data collection infrastructure. Meanwhile, those whose data were not captured, from birth records to financial transactions, may be left out from government benefits or accessing credits in the future. So being part of this digital economy is also important while respecting the privacy. Lack of cross-jurisdictional practices around sourcing, use, and non-disclosure of artificial intelligence training data could threaten the rights and result in economic concentrations, meaning the inequality around the world. United Nations suggests that through international artificial intelligence governance could enable and catalyze more diverse participation in leveraging data for artificial intelligence for all. The above summarizes the contents that I was able to collect and organize in the fashion that I just relayed to you. And if any of you are interested in terms of the greater details of the GDC, the Global Digital Compacts, what Jenny may be able to share with you in terms of resource and some of the the greater details. With that, I turn the the microphone to back to the host.
Okay, thanks, Alan. And as Alan mentioned about the GDC, then here's the QR code, and you can scan the QR code for more information on the United Nations website. Or after the meeting, I can share the link to the TCA and just forward to that more information to you, to all of you. So I think I'd be a little bit run out of time, but we hope that the initiative shared today have helped you guys learn more about Big Object and the topics of the UN is concerned about. And we appreciate to your interest and participations. And if you have further questions or further information, Dr. Wenwei, Alan, and I will also be attending the annual meeting in Tokyo next month, and we'll be looking forward to meet you guys there. And you can also contact me via email to arrange another online meetings. And we look forward to see you guys person next month. So now I'll pass the microphone to the host. Thank you, guys.
Thank you, Jenny-san. And we will send through video as well for your presentation. So we can know much information, including big vision and movement, sound data, and as well as digital area. I believe it was very insightful for all participants. So usually we will move on to the quick Q&A session, but we should skip the Q&A. Is it good for you, right?
Yeah, no problem. Thanks.
Yeah. Yes. Okay. So thank you very much, Jenny-san. So let's move on to the next agenda. Next is the closing remarks. Before closing this working group, I would like to introduce our future work to the AODP summit. As I already said, we will make a report and bring it to AODP summit next month. For that, we make a draft and share it with you to receive your comment. After considering your comment, we will finalize the report at the summit. So that's all of my closing remarks. Do you have any comments or questions about it? Yes, okay, I will know. So it's time to close. Finally, I would like to thank once again to speakers, Gopal-san and Jenny-san, as well as Wei-san. I also would like to thank all members joining this working group. I look forward to seeing you at the summit, hopefully in person next month. So I would like to adjourn this meeting. Meeting is adjourned. Thank you very much.